Okay, this is the first example problem here. And so I'm going to cut this into three little videos here. What is the voltage across these plates? What force on the electrons? What is the force on the electrons between the plates? What is the downward acceleration? Here are the answers at the bottom. And let's get these first three answers here, right? Okay, so it's the electric field is 9420 volts per meter, right? And they enter midway between the plates, right? And they nearly strike the bottom plate, right? Okay, so the first thing I'm going to do is figure out the voltage. And this isn't so hard. I'm going to use E is negative delta V over X, right? Okay, and they almost hit the bottom plate. So by the way, the bottom of this is actually positive, and the top is negative, right? Okay, what is the voltage across the plate? So we know the electric field. We know that it's 10.2 centimeters apart, right? So this times this will give us this, right? So our E is equal to 9420 volts per meter, and our X is equal to 0.102 meters, right? So I'm going to just multiply those two. 9420 times 0.102, and I'm going to store that in E. And I get 960.84. Okay, I'm going to store that. Yeah, there we go. That's not the electric field. I'm going to store that in voltage, V. Okay, there we go. Okay, now the next one says, what is the force on the electrons between the plates? Well, okay, I'm going to use F equals EQ, right? The formula is E equals F over Q, right? Right, so the force is going to be electric field times charge, right? So it's going to be force is 9420, and that's newtons per coulomb because that's the same as that, right? And then it's an electron, so it's 1.602 E minus 19th coulombs, right? So 9420 times 1.602 E minus 19, and I'm going to store that in F for force. And I get that it's 1.509084 E minus 15th newtons, right? And then what is the acceleration? I'm going to use F equals ma, right? And the mass of an electron is this, right? And the force is this, right? So A is F over m is 1.50908 E minus 15th newtons divided by the mass, which is 9.11 E minus 31 kilograms. Okay, so divided by 9.11 E minus 31. I'm going to store that in A. So there's my acceleration. I'm getting 1.6565137 meter, oh, this is important, times 10 to the 15th meters per second squared. Okay, so that's the first three things, and this is a typical progression, right? You tend to either do this way, this way, this way, or this way, this way, this way. Okay, so that's the first three, and then in the next video, we're going to do the little Suvat thing, horizontal, vertical, and then the next video we'll do how you know that the accelerating potential before it reached this thing was that many volts. Okay?